Hey guys, I had a quick question about number 6. This assignment was from last Wednesday. It was from this first linear equations homework. So in this section, we did look at tables and we are looking for that constant difference here. But this is only when one value grows by equal differences. So that's like these all went up by 1s, these all went up by 2s, these all went up by 3s. So what's tricky is all of a sudden they give us 1, and I wrote the differences here. This one went up by 9, this one went up by 12, this one went up by 3, this one went up by 4. So the problem says that they disagree with each other and they want you to show algebraically. So I did a couple different things to try to think of the best way to teach this. You could plot all these on a graph and see if they form a line, but they algebraically, what we know how to do, is we know how to find the slope. So you can find the slope between these 3 points. So -6 and 5 and 3 and 8 would be 1. You could do -6, 5, and 15, 12. And then the last one would be 3, 8, and 15, 12. These are the 3 different combinations that you could find the slope of. So with that, our slope formula, if you guys remember, is y2 minus y1 over x2 minus x1. x1, y1, x2, y2. So this one is going to be 8 minus 5 over 3 minus -6. 8 minus 5 is 3, and then if you take this, remember, you subtract a negative, it turns to adding, so this is over 9. What is 3/9 reduced to? 1/3. Okay. So our next one, we would have x1, y1, x2, y2, 12 minus 5 over 15 minus -6. 12 minus 5 would give us 7. And 15 minus 6, this is going to be addition, so this gives us 21, and this reduces to 1/3. So far we've got the same answer. And then our last one, find another color. x1, y1, x2, y2, 12 minus 8 over 15 minus 3. 12 minus 8 is 4 over 15 minus 3 is 12. That also reduces to 1/3. So the slope between all 3 of these points, no matter which way you do it, is all the same. So if the slope matches, that means it's constant. It's going up at the exact same rate. So it would be a nice, smooth, straight line. And that's exactly what we need to be linear. So is this an algebra, or is this a linear equation, a linear function? Yes, it is linear. Now I know that seems like a lot of work. So for those of you that like shortcuts, there is one way to look at this. You can take the differences in the tables, and if the difference of the y's, so I took like 8 minus 5 and 3 minus -6, and the differences was 3 over 9. Well, was 3, the difference of the y's over the x's would be 3/9, which reduces to what? 1/3. So same thing here, 4 to 12. Well, what does that reduce to? 1/3. So you can check it like that as well. That's a pretty sound way to check to see if they are the slopes reduced to the same thing. So I hope that answered your question. Like I said, if you're going to these ones, if they go up consistently by the same value, you can use that method we talked about on the other side. So these all went up by 1s. and these all went up by 2's, so then yes, it's linear. But if it gives you a funky one, you can still use that slope method.